Hi, welcome to Module 1 for NOS 130. Some of this you've seen already, what to expect. Like I said, I'll have three major sections in each of these modules. I'll have information assignments and exam. Normally I won't have this section in future ones, but I will post the basic learning objectives that the author's trying to display or to instruct in this class for this. So we'll look at the difference between peer-to-peer and client-server networks, different types of applications and protocols. Protocols are just a set of rules that allow two computers to talk to each other. Just like the same way you have rules in talking with somebody on the phone or when you meet them face to face, you have, even though they may not be written rules, there are certain rules you use in holding a conversation. So that's kind of what we're talking about here is what kind of rules are needed from both parties to have a conversation, to transmit data back and forth. Chapter will talk about different hardware devices, what are the most common layouts, physical layouts, because you got a physical description or physical layout, a physical topology. Topology is basically just a map, how things are laid out physically, but that doesn't necessarily mean that's the way the data is going to flow. So you're going to see the term logical topology and physical topology. Physical is how things are wired together, which physical devices are connected to each other, and logical says which way is the data flowing. That way you can kind of tell the difference there. We'll talk a little bit about the next, you know, what types of devices, what kind of physical network devices are in those physical environments, what kind of cables, what kind of routers or switches or computers, because when you use the network you use today, you've got your phone, you have your laptop, you've got your TV. Some places have a refrigerator that's on their Wi-Fi. Or in my case, I got my garage door opening and closing on my Wi-Fi. My printer's on my Wi-Fi, so I can communicate to it. Those are all network devices and how they're connected. Now, we mentioned protocols up here, that some of those protocols in setting up those rules in how to basically talk to each other. There's an organization, Open Systems International. It's a French term, but it's an open systems model group that got together worldwide and says, okay, let's talk about how we're going to get data from all the way from the physical connections, how are things going to plug together, and all the way to the top as to which applications are going to run. So there's 7 layers in this process that every piece of information goes. Now, you look at it and says, OSI, I've never heard of that. But most of us have heard of TCP/IP. Well, TCP/IP is another set of rules that allow people to communicate. And what happened is the group that got together to form TCP/IP actually finished their rules and regulations before the OSI model was totally finished. So what has kind of become the de facto standard is TCP/IP is what we use today application, and there could be 4 or only 5 layers in that model, but in those 4 or 5 layers, the same things have to take place as described in the 7-layer OSI model. So they kept the OSI model 7 layers only from the standpoint for is it easier for developers for future rules, and as new technologies and new things come out, to be able to split it into smaller pieces than it was as it was in the TCP/IP. So OSI is more of a training tool, a design tool, a discussion tool versus an application tool. Then there's some conversation on best practices when you're working with networks and working with computers. Some of you that are working on your Net Plus certifications or your A Plus certifications on the hardware side, you understand a little bit of what it takes to prevent problems to happen when you're working with a physical computer. And then we'll look at troubleshooting and uh, what's the best way to do this. So that's what this chapter is all about. Now, some of the links I've got in here are, as you can see, you've got network topologies, we got client server applications, because I think that was one of the here, you got peer-to-peer client server information. And then I've got troubleshooting, which was, I think, this last section here, how to troubleshoot networks. Another one on peer-to-peer and client server, a OSI. Now, these links are descriptions. They're websites that describe these things. But I also posted, whoop, what did I just do? Get back here. Then I post videos, in this case, just again, for those that are more visual, you actually can see some of that description. So each week I'm going to post things similar to that so that you can understand a little bit better. Now, if your book is totally linked up, you can click this read. It'll go to the textbook and allow you to proceed with at least the reading part of it. The assignments, all the assignments this week are due 28th at midnight. And then I've got 5 labs down here. We'll have to play games, whether these, like I mentioned before, whether the simulation labs or the virtual machine labs, which ones I like better as the semester goes on and based on this textbook goes on. And then you have your exam. Now, 20 multiple choice, 30 minutes, 2 attempts, I take your highest score. So clicking any one of these links takes you directly to that assignment. So if we just take you quickly to the reading, there we go. And it gets you to module 1. Into the reading. Now, the most of this chapter is a lot of new concepts. You can kind of think of networking as a second language, a foreign language. So what you're going to see in this chapter is kind of explain the differences between everything and give you a bunch of terms that you'll try to file away in your head to understand. But some of these are relatively, that when you think about it, if I look at peer-to-peer networks, that means computer to computer. Have you ever tried to take 2 iPhones and share a data between them and get them really close together? That's a peer-to-peer network. I've got 2 computers. Or remember growing up that you played, put 2 tin cans and a string together and be able to talk to each other that way. Or a walkie-talkie. That is peer-to-peer, as you're going just one device to another device. The client-server model is probably one you've used your entire life. From the second somebody gave you a phone that had access to the internet, you were on a client server. You're the client. The server has all the data that you need access to. So that is probably the one you use the most, is that you make a request to the server and the server then says, oh, you want a web page. And you, of course, what did you do? You told it, I wanted to go to You Google the site, and you click the link, and it says, I want that web page to come up. Well, that web page went out to the server. The server says, oh, let me go through and see that. Let me see if I can pull that off. See if I've got access to it. Where do I have to go to get access to it? So now to do that, there are several services that are available. And if you look in this network services and the protocols, which set of rules are used for the network services? And here, like I said, protocols, they're used as just a set of rules that you want to proceed with. TCP/IP. Now, the ones you're probably used the most is definitely anything to do with the website. And for the most part, you all recognize HTTP. I mean, the website on this screen is too big. I can't see the start of it, but that'll start with HTTP. Now, if you go to your bank and make that request, you want to do your bank, you want to do that a little bit more secure. You want to put a password. You want to guarantee that the data is protected. And there's two ways of doing this, either with secure socket layer or with the transport layer security. The vendor has a choice. In this case, once they choose, the website will then be HTTPS secure. So into this, even when you're talking to a network, it is exactly what you thought it would be. You says, I made this request, and it's going to use on this client server, you've made a request, and based on the rules of how you're making that request, it'll say, where is this data looking for? Where do I go? What do I use to make that all happen? And here you just got an example of that. Another one is email services. And there's 3 different types of email services. There's simple, post office 3, and an IMAP 4. Each one of those has a little bit different way they used. Sometimes it's just, once you get the information, I'm going to deliver it, and I'll hold on to a record of it. Or I'll just give it to you, and it's up to you to decide. Now, POP3 email is just downloaded, and it removes it from the server. It doesn't keep a record of it. It's forcing you to decide what you're going to do with it on your end. IMAP 4 is a little bit different, and it's probably one that when you look at Microsoft email, Exchange server, if you use Outlook or Google Mail, what happens? You can read your mail, but it isn't put on your computer. It's just still kept out on the server for you to access at a future look in time. So that more than likely is telling you it's using an IMAP 4 protocol, set of rules on how to do this. Now, other protocol services is, do you have to remember the name of every single web server? Well, no. But when you say, why do I have a mailin.edu? What's that mean? What they've set up is this domain name system defines a set of rules on how to define a URL, or the name that goes into your server, your search bar. It's decided I'm going to put those on different servers. So I don't have to have everything in the same place. I can have one for education, one for business, one for companies, one's for the federal government. But it just says, but to do that, I had to set up a set of rules to how do I want to define a set of computers associated with my company, business, or organization. Now, one of the things you like to do is be able to send data. I want to be able to transfer data. And of course, there's a couple of different ways of sending data. And file transfer protocol is one of those set of rules that allows you to do that. Of course, you've got a secured one. You've got database service. You've almost heard of MySQL or SQL. Those are a set of rules on how to organize data that you can query. You can store the data, query it, print reports, things like that. Remote access service. This is latest. How do I want to get access to somebody's other computer? And there's a few of those. There's an older one called Telnet. There's one called Secure Shell, that SSH, or there's remote desktop. So if I want to remotely get into somebody's desktop, if you've ever had trouble with a computer and you had a guy from Best Buy log in and run a program remotely from you, more than likely he's using a remote desktop type application that allows him to communicate directly to you, both securely and messages encrypted so that you can see this. So having a client server allows you to, I'm not going to go through all this stuff, information that allows you to go into, to share information, gives you a set of rules to do certain applications that you're all relatively used to doing. Now, hardware, a bunch of stuff that we were all used to. Now, trouble is more than likely of us, most of us are only used to end devices. You know, printers, computers, Chromebooks, laptops, iMacs, and they're connected. I look at the one that I've got on my desk right now. Physically, the only thing it's connected to is the power cord. But through my wireless application, which basically says I now can create a switch that says I can log in remotely, wirelessly to my switch, which then says any information that I want to send someplace else, either to a website outside of my organization or outside of my home, or even within my home, it allows me to send that data. It knows where my printer is, so I can be in the living room, send a job, goes to my printer. Well, this switch access allows me to do that simple exchange between physical devices. Now, there are several different types of networks. Probably the one you are more familiar with is a local area network. That's usually a smaller network that for an office or a campus, it has a router to get access to other networks, switch that allows me to connect data to other devices inside my network. Now, this local area network can be designed several different ways. And each one of those physical topology has different benefits. You get what they call a star network, and you can kind of picture that in your head going, what is a star? Let me see if they don't have any pictures of that. Not yet. Okay, I'm not going to go through that. But so pay attention to what the topologies are, because each one of those topologies has a pros and cons, and as the network designer, you will have to pick and choose which way they go. Now, most network are kind of a mesh network where it's a combination between a star network where you've got a central point of contact, but then what happens when I have to add another network and another network? I don't want to have to keep building my star. I just want to keep growing up. So pay attention to some of these topologies. They all have benefits. Some are still used today, some are not. ring topology is one that's not used very much because it's got a high break point. It will fail pretty much once it fails at one point. You can't communicate around the circle anymore in the ring. So now the switch is used for inter communication with inside your local area network, but a router is a device that says I need to communicate between a different network. And if you think about what is the internet is just a connection of networks. And to get there, you need a router, a device that says, where is this server in the internet? So this router gets you between two or more networks, and that's its main purpose. It worries less about getting information between devices, but it wants to get information between one network, the school's network, or your home network, to the school network, which then says, oh, now I got to go where Cengage is. I got to go out to the internet and find out where that is. That's what this is. Now you're going to hear the term SOHO, that's small office. It just gives you a rough idea. And most of what you have at home, more than likely, based on how old your network is, you may at one point in time had a separate switch and a router. Most of us today have a combination that if you look at your wireless router, you have switch port, you have part of it that looks that everything can plug into, either wirelessly or wired, and go through there. So your internet service provider is the person that provides you. That's the one you say, I want to get access to. So is it AT&T? Is it Verizon? Is it whoever your internet service provider is? Comcast? All of those companies now helps you communicate across not only one LAN, but across multiple LANs. Here's an example of one router connecting three separate LANs. So, and you can consider these like Malin's system, that each building, could even be each floor in a building, is set up on its own network. And then the router says, oh, I'll take, if I want to go from network C to network A, there's no physical connection between them, but the router's the one that knows when you're saying send a service request from network C to network A, the router knows how to get there. It knows I come on one interface, I leave on a different interface. So its tables know the best way to do that. Or if it's not even on your campus and it's someplace else, another thing to play with. Let's see other things we want to. Now there are different types of LANs. You had a local area network, which usually handles like our campus. But you can have what they call a wide area network. And basically that is more of a geographic, how large of a larger area is it trying to cover? So think of geography when you're talking about a wide area network. You can have a MAN, which is be a metropolitan, so a city could have this. Or in this case, they've also said you can have a campus area network. So all of this location of a network is pretty much what area am I trying to cover? So am I doing it personally for a personal area network? Am I doing it for a wide area because I'm doing a large geographic area? Or is it just our campus, that its own little network that's nobody else can get access to? And this kind of gives you representation as size represented. The ones that we deal with probably the most that we would understand personally, because right now, what do you do when you get in your car? Your phone connects to what? A device on your car, so you can hear the car, your phone over the car. That's a personal area network. It's got a very short distance that those allow to connect with. Local area network at school, and then the wide area network that we allow to connect between here in San Francisco or Paris or wherever. So in this case, you've got San Francisco to Philly, and they've got their own separate networks, and you've got a separate, different type of physical connection between those, and actually it'll switch between different media that your data transfers across, but all those are protocols that are done. Now, other types of network, I'll let you go through some of those. One that is most of us like is, what is our wireless network? What is my wireless local area network? What does my network at home look like? That would be something like that. Now, the 7-layer, it's an open systems interconnection description, and basically it describes how do I get data from one point to another. Just think about if you were writing a letter and you want to send a letter to a friend of yours in Chicago. What would you do? You'd write the letter, you'd fold it up, you'd put it in an envelope, you'd put a stamp on it, put an address on it, put a return address on it, put it in the mailbox. Mailbox guy would pick it up in the truck, take it to a post office, and then reverse that whole process till it got back to the person in Chicago that you're looking for. There are protocols for that. The same thing happens with when you're sending data between the two. And I kind of like that model of sending a letter as far as exactly what happens when you're sending data from one computer to another computer. The open source, open systems interconnect reference model, it's 7 layers. And basically it just says here, this is where all my applications and protocols we looked at, whether it's FTP, your email service, your internet service, it falls onto these 3 application layers. Even though in a TCP layer or model, there isn't as many layers. You kind of see how many different layers there are based on the color scheme they've got here. You've got one that's hardware related, so basically what is its physical layer? How am I going to use electronic? Am I going to use electricity to send data? Am I going to use light? Am I going to use wireless information to actually represent ones and zeros? How am I going to connect them? How am I going to address this information? Am I going to send data protected or not protected? Which applications am I going to use? How am I going to present the data? And then which applications, who actually made the request? It's client server. So you're saying I'm trying to get access to the internet, so I make my request, and it's got to go all the way through this process. Now, I'm not going to go through all of these. There are some acronyms that are good to remember, those 7 layers, and it really, you want to go top down, bottom up. That's really up to you, but here are 2 of them. One that's going top down, all people seem to need data processing. So it takes you all from application down to physical. Or bottom up is please don't throw sausage pizza away. So it just takes you from the bottom up with please, for the physical data link, network, transport, so on, all the way up to session processing. So that one of those 2, or make up your own. That, the one I always liked, I took, instead of please, I did programmers do not throw sausage pizzas away, only because I had a long time in programming. So that seemed to make sense to me. So because you're going to need to know those layers. Now, each one of these layers has a function. So you're going to go through and you're going to look at the different types of functions. I'm not going to go through each one of those just so you can see, but each layer has a specific purpose. And you'll be able to see as you look back to that first picture where it had all 7 of them and they had different colors. TCP/IP didn't have the 7 layers. It kind of grouped them in a more logical way. Now, as you go through those different layers, there's going to be something that in that layer that's going to do something to the data. And what it's going to do when it gets data, it's going to create a protocol data unit, a PDU. And basically it says, what am I going to do with the data that was sent to me? How am I going to apply the information that my layer has to that data that needs to be sent? And so you're going to want to pay attention to the layers, look at the name, and pretty much for the first 7 layers, it just called the payload or the data. You don't really do a lot with it. But now when I start getting down to the transport layer and says, okay, how do I want to send the data? Then you're going to get several different layers here. So it's going to go from payload and data down to layer 5. Then you're going to get a segment or datagram based on which protocol you want to use. When you look up the definitions of TCP or UDP, each one has its benefits and purposes. You'll want to know those. The network layer is the packet, the data link layer is the frame, and your physical layer is just what bits. How am I going to represent my bits? Is it going to be electricity? Is it going to be electronics? What is it going to be? Now, all of these layers tie together. As you saw in mailing a picture or a letter, a piece of information, you wrote it, you folded it, you stuck it in an envelope. Now, as you're going up and down those layers, you're adding or subtracting information to it. So when you are going down the layers, when you're adding information to it, you're encapsulating, you're encompassing the data that was sent from the previous layer and putting your information on it. And each layer is a little bit different. Each PDU is either doing that. Now on the receiving end, I got to read that header information at my particular layer, decide what to do with it, take my information off, de-encapsulate the information off, might take off my header information and pass it on the next layer. Well, this information, as you look at this picture, is each of the devices even says, I only have to worry about how far do I have to look on all the data that's been sent. A switch only looks at the first 2 layers. A router says, I got to get to the network layer, says, is that network within my building or someplace else? If it's someplace else, then pass it on. So each device, a switch looks at 2, router looks at 3, the server looks at all of them because it says I'm looking for what data am I looking for. So I'm either going to encapsulate or de-encapsulate that information. And then you can look at table 1, 2 to see which layers are going through. So you want to make sure. Now, OSI is great for learning and education, but TCP/IP is the one that's used the most. And for the most part, they've grouped 3 layers into 1, which then gets you down to 4. But for the most part, when it looks to what you're going to build in the world, it's TCP/IP. But when you're looking at the logic of how the data is being manipulated along the way, Net Plus is going to look for you to know that. I'm not going to go through the safety and procedures. You can look at that information. What types of things would I protect my security on my devices, whether it's building, data center room, a particular rack inside a data center? What kind of rules and regulations did the federal government put on us about protecting health and safety? Let you look at some of those rules and regulations. Now, troubleshooting is something that you always have to look at. And troubleshooting, actually, the OSMI model is actually a pretty good model for depicting a network as far as which way am I troubling. Am I going to work from the top down or the bottom up? But the basic steps are, you're going to identify the problem, its symptom. You're going to say, okay, what could be the probable causes once you've determined what could be the problem. Then you're going to say, what, test my theory. Test if I think that's a particular reason, can I prove it? And then once you've done that, you want to set up a plan to resolve it. And then you want to implement it, and then you want to verify it. And of course, what you want to do, which most companies fail miserably on, is document what you did and where is the system at this moment. So those are things that you want to think about there. So hopefully this gives you a brief idea with a highlight of some of the things to concern yourself with. Different areas. I think there's nothing else I want to. Tons of terms, and of course you can look up those terms. And like I said, networking is a foreign language, so you're seeing a lot of data, a lot of terms that you want to become familiar with. So hopefully this helped. And not, give me a call and we'll figure out, or send me an email and we'll find a way to get you the answer. Have a nice day. Bye-bye.